Hello my dear friends, welcome to all of you. Myself Dattu Patel, Assistant Professor from LJIT. Today's session we are going to discuss about the method of undetermined coefficient. See, earlier session we are already discussed about the shortcut cases to finding the particular integral. In such kind of method we can also find the particular integral and then after we solve the general solution. Let's move on the method of undetermined coefficient. In this particular method we can use to find the particular integral only if linearly independent derivatives of q of x as well as r of x, and it will be finite in number of derivative terms. That means this restriction implies the q of x that can only have the terms such that k, x raised to n, e raised to x, sin ax, cos ax, etc. and the combination of such kind of terms where k and a are constant and n is any positive integer. Such kind of particular method when q of x, which is in form of 1 upon x, tan x, sec x, etc. since each the functions has an infinite number of linearly independent derivative terms, we cannot apply directly. For that we should apply another method, which is method of variation parameter. In this method we can solve when the our r of x or q of x, which is in terms of 1 upon x, tan x, sec x, etc. In this method particular integral is assumed as a linear combination of the terms in q of x and its linearly independent derivative terms. Some of the choices of the particular integral gives as below in table. See, whenever our q of x, which is exponential form, then its family, which is a e raised to x, where a is indicated by the undetermined coefficient. Suppose our r of x, which is sine and cosine terms, then family which is sine ax plus b and cos ax plus b, where a and b are undetermined coefficient. See, suppose our r of x, which is in terms of polynomial form x square, x cube, x raised to n, etc. then its family is an x raised to n plus an minus 1 x raised to n minus 1 plus n, so plus a2 x square plus a1 x plus a0, etc. This all the particular integral or linear combination in terms of particular integral. In this table values of a, b, a0, a1, a2, a3 and so on are the undetermined coefficient. See how we can find the linear combination of such kind of term or such kind of particular integral. For that, suppose our r of x equal to or q of x equal to sin ax. Now derivative of that particular term, then derivative of sine, which is cos ax into a, derivative of cos, which is again minus sin ax into a square, again derivative, then minus cos ax into a cube and so on. Now such kind of r of x, derivative of infinitely, then we get the one term which is cos, another term which is sine. Neglect negative sign and whatever the constant term which is multiplied at that particular position. We neglect these all things. We require only functions which is sine and cos. Then family of r of x is in curly bracket cos ax and sin ax, or we can written as a sin ax or cos ax. Similarly, suppose our r of x equal to 8x square, the derivative of that particular term, then first 8x square, then derivative 20, 8 2s are 16 x, then again 16, then neglect all the constant terms. We required just x square, x and constant term which is 1. That means family of r of x is x square, x and 1. See, suppose we have the in terms of exponential function r of x equal to e raised to 7x, then family of e raised to 7x is in curly bracket e raised to 7x, because whenever we derivative of that particular term, then 7 e raised to 7x, again 49 into e raised to 7x, etc. Then our constant term will be neglected out, that our function in terms of x which is e raised to 7x. Then family of exponential function which is exponential function. Suppose sometimes our function or r of x which is in terms of product form, then r of x equal to x square plus e raised to x e raised to 3x. At that case, what we have to do? Then total family of x square which is x square, x and 1 which is union with e raised to 3x, means family of x square union family of e raised to 3x. Then family of x square which is x square x1 and family of e raised to 3x which is e raised to 3x. Then total family of r of x is x square x1 and e raised to 3x. Now we just find the linear combination equation. Then yp is equal to whatever the family member which is multiplied with a, b, c, d, otherwise a1, a2, a3, a4. Then a1 x square plus a2x plus a3 plus a4 e raised to 3x, where a1, a2, a3, a4 are undetermined coefficient. Similarly, suppose our r of x which is x into sin ax, then first finding the family of x, that is x into 1, family of sin ax which is sin into cos ax. Now whenever our r of x which is in terms of product form, then product form of the family, that x into sin ax, x into cos ax and sin ax into cos ax. Now our yp which is whatever the family member which is multiplied with undetermined coefficient, which is a1 is equal to x sin ax plus a2 x cos ax plus a3 sin ax plus a4 cos ax, where a1, a2, a3, a4 are undetermined coefficient. Here whenever we written as a yp, that is ax square plus bx plus c, where a, b, c are undetermined coefficient. Let's move to the solve the one example based on method of undetermined coefficient. Solve the d square minus 2d plus 3 of y is equal to x cube plus sin x. Firstly, what we have to do? Whenever we solve this such kind of problem, we require two solutions. One is complementary function, another one is particular integral. Firstly, discuss about the complementary function. For that, we require the auxiliary equation. Auxiliary equation is m square minus 2m plus 3 equal to 0. Now factorize that particular term, that will give you m is equal to 1 plus or minus I root 2. Here our factors are complex pairs. Then we use the case 3 of the yc. Here values of a is equal to 1 and values of b is equal to root 2. Then yc is equal to e raised to ax c1 cos bx plus c2 sin bx. In this formula, substituting the values of a and b, then e raised to x c1 cos root 2x plus c2 sin root 2x. That is our equation number 1. Now let's move to the finding the family. Here our q of x equal to x cube plus sin x, means which is in terms of addition or subtraction form. For that, what we have to do? First find the family of q of x equal to family of x cube, which is x cube x, x square x and 1 union family of sin, that is sin x into cos x. Such kind of term we just whenever our q of x which is in terms of addition or subtraction form, then we just finding the family of x cube union family of sin x. Then our total family which is x cube x square x 1 sin x and cos x. Now linear combination equation which is yp is equal to ax cube plus bx square, otherwise we can use a1, a2, a3, a4, a1, a2x square plus a3x plus a4 plus a5 sin x plus a6 cos x, where a1, a2 up to a6 are undetermined coefficient. Now, derivative of that particular term with respect to x, then this one is a yp dash, or we can say yp first time derivative, second time derivative, which is 3a1x square plus 2a2x plus a3 plus derivative of constant, that is 0, then a5 cos x minus a6 sin x. Again derivative of that particular term with respect to x, then d square y 6a1x plus 2a2 minus a5 sin x minus a6 cos x. Now this all the derivatives which is substitute in our question, which is given differential equation. That means substituting this derivative in our given differential equation and simplified it. Let's substituting it, then d square y minus 2dy plus 3y is equal to x cube plus sin x. Here 2 times derivative term, which is 6a1x plus 2a2 minus a5 sin x minus a6 cos x, minus twice as it is single time derivative terms inside the bracket 3a1x square plus 2a2x plus a3 plus a5 cos x minus a6 sin x plus thrice y, which is kept as, that is our yp, a1x cube plus a2x square plus a3x plus a4 plus a5 sin x plus a6 cos x is equal to x cube plus sin x. Now just expanding the brackets and need to simplify it, then 3a1x cube plus minus 6a1 plus 3a2x square plus 6a1 minus 4a2 plus 3a3x plus 2a2 minus 2a3 plus 3a4 minus twice inside the bracket a5 minus a6 cos x plus twice a5 plus a6 sin x equal to x cube plus sin x. Now this one is a simplified term. Now we just finding the values of a1, a2, a3, a4, a5 and a6. For that what we have to do? Obviously equating the both sides, that means comparing the coefficient on both sides. That will give you firstly coefficient of x cube, then here 3a1 and here coefficient of x cube, that is 1, then 3a1 which is compared with 1, then 3a1 is equal to 1, then a1 is equal to 1 by 3. Similarly for the x square, comparing the coefficient of x square, minus 6a1 plus 3a2 is equal to 0, then simplified that term and substituting the values of a1, that is 1 by 3, then 3 2s are 6, then a2 is equal to 2 by 3. Similarly equating the coefficient of x with 0, then 6a1 minus 4a2 plus 3a3 is equal to 0, and simplified that term, and that will give you, here we have the values of a1, that is 1 by 3, simplified that term, that will give you a3 is equal to 2 by 9. Similarly a4 is equal to minus 8 by 27. Here we equating this equation, that will give you a5 is equal to a6. Substitute these all things in our equation number 1, which has a yp has a a1 has a 1 by 3 x cube plus a2 has a 2 by 3 x square plus a3 has a 2 by 9 x minus a4, that is 8 by 27 plus 1 by 4 sin x plus cos x. That is the equations of yp. Now general solution is combination of y of x equal general solution, which is complementary function plus particular integral, means yc plus yp. Substituting the values of yc and yp, which is e raised to x inside the bracket c1 cos root 2x plus c2 sin root 2x plus 1 by 3 x cube plus 2 by 3 x square plus 2 by 9 x minus 8 by 27 plus 1 by 4 sin x plus cos x. Let's move on to one more example. See, solve the y double s plus 4y is equal to 8x square with the help of method of undetermined coefficient. Firstly, what we have to do? Y double dash, rewrite this equation. That means d square plus 4 of y is equal to 8x square. That auxiliary equation is m square plus 4 equal to 0. Then m square equal to minus 4. Then n is equal to plus or minus 2i. Here values of a is equal to 0. Values of b is equal to twice. Then yc equal to c1 cos 2x plus c2 sin 2x. Now here our r of x equal to 8x square, then family of r of x is x square, x and 1. Then our yp is equal to ax square plus bx plus c, where abc are undetermined coefficient. See, now derivative of that particular term, which is 2ax plus b, again derivative which is 2a. Now substituting this yp dash, yp double dash in given differential equation, then y double dash, that is 2a plus 4 yp, that is ax square plus bx plus c is equal to 8x square. Now just expanding this term, then 4ax square plus 4bx plus 4c is equal to 8x square. Now simplified that term, that means 4ax square plus 4bx plus 2a plus 4c equal to 8x square. Now comparing these equations, that means equating the coefficient both sides, that will give you 4a equal to 8, 4a equal to 8, 4b equal to 0 and 2a plus 4c equal to 0. Then here a is equal to 8 by 4, means values of a, that is 2, values of b, that is 0, values of a which is here, then 2 into 2 plus 4c equal to 0, then 4 plus 4c equal to 0, then c is equal to minus 1. Now substituting these values of a, b, c, then ax square plus bx plus c, that means yp is equal to 2x square minus 1, that is our yp. Now y of x equal to yc plus yp, that is a combination of complementary function and particular integral. Then yc, which is c1 cos 2x plus c2 sin 2x, and yp, which is 2x square minus 1. That is our general solution. Let's move on the one more example. Solve the y double s minus 4y dash minus 12y equal to e raised to 6x. See, firstly auxiliary equation is that m square minus 4m minus 12 equal to 0. Then here 6 2s are, then m square minus 6m plus 2m minus 12 equal to 0. Then m which is common out, then m minus 6 plus 2 which is common out, m minus 6 equal to 0. Then m minus 6, m plus 2 equal to 0. Then m is equal to 6 minus 2. Then yc equal to c1 e raised to 6x plus c2 e raised to minus 2x. That is our equation number 1. Now just finding the family of r of x. See, here family of e raised to 6x is e raised to 6x, which is contains solution, the corresponding homogeneous equations, which is y double dash minus 4y dash minus 12y equal to 0. So we cannot proceed further with most general linear combination of the functions in the family e raised to 6x. So we required to modify the family members. For that, what we have to do, e raised to 6x, which is x e raised to 6x, means multiply by x to the each family members. then yp is equal to a x e raised to 6x. Now here we modify the family members, then yp dash, we require the yp dash and yp double dash. See, yp is equal to a x e raised to 6x, then derivative of that particular term, a which is constant, u as it is, derivative of v plus v as it is, derivative of u. Just simplify that particular term, then ax e raised to 6x plus a e raised to 6x. Again derivative, then 6a which is constant, product rule u as it is, derivative of v plus v as it is, derivative of u plus 6a e raised to 6x. Need to simplify that term, then 6 6 are 36 ax e raised to 6x plus 6a e raised to 6x plus again 6a e raised to 6x. Now substitute these all things in our given differential equation, then yp double dash, that is 36ax e raised to 6x, 6 plus 6 that is 12 e raised to 6x, then y double dash minus 4y dash minus 12y equal to e raised to 6x, then y double dash which is 36ax e raised to 6x plus 12a e raised to 6x minus 4 y dash, that is 6ax e raised to 6x plus a e raised to 6x minus 12 y which is ax e raised to 6x equal to e raised to 6x. Just expand these things. Now 36ax e raised to 6x plus 12 a e raised to 6x minus 6 4s are 24ax e raised to 6x minus 4a e raised to 6x minus 12a x e raised to 6x equal to e raised to 6x. Now 24 plus 12, 36, 36, this term will be cancelled out. 12 minus 4, that is 8a e raised to 6x equal to e raised to 6x. Now equating both sides, then 8a equal to 1, then values of a, that is 1 by 8. Now yp is equal to ax e raised to 6x, then values of a, that is 1 by 8 x e raised to 6x. This one is our yp. Now substituting the values of yp and yc in our general solution, then general solution is y of x equal to yc plus yp, then yc equal to c1 e raised to 6x plus c2 e raised to minus 2x plus 1 by 8x e raised to 6x. That is our general solution, where c1 and c2 are arbitrary constant. This example you can also solve by the shortcut method has a case 1, where r of x or q of x equal to exponential form. At that case we replace d equal to a. You can apply method of undetermined coefficient as well as shortcut method. Let's move on to one more example. Y double s plus 9y is equal to 2x square, which is try yourself as a homework. Another one is a y double s minus 2y dash plus 5y equal to 25x square plus 12. Such kind of example, we just finding the family first, 25x square, which is x square, x and 1, union family of 12, that is 1, then total family which is x square, x and 1. Similarly here, just finding the families of x square, x and 1, which is family of 2x square, union which is families of e raised to minus x, and total family which is x square, x, 1 and e raised to minus x. This all the example you can try yourself as a homework. I hope you guys you learn something from this video. If you like this video, then thumbs up. If you think that this video will help some of your friends, then do this, share with them. If you want to watch more tutorial like this, then you can subscribe my YouTube channel and whenever I upload the new video, you get the notification. If you have any query regarding this, then feel free ask me, feel free contact me. Thank you so much for watching me.